Okay, starting in 5, 4, 3, 2, 1. Network is not working or what? Well, let me check once. Wait, guys. Yesterday, that kind of problem happened. Like uh, sound was not there on YouTube. On lecture number 11. To see if it is working. Once. Wait, guys. Yesterday, that kind of problem happened. Yeah. It's coming. Good. Great, Anurag, Mr. Okay. So we'll switch on the YouTube live stream, whether someone will ask questions or not. You can see on that. Go live. Okay. Advanced 360 pixels. Yes. Everyone can hear me perfectly? Yes or no?
Yes, sir.
Okay. Okay. So let us start. So today we are going to deal with this particular velocity time graphs. Okay, means this was the most important topic which was left all during the course. Okay, so today we are going to deal with it because this is a kind of thing, means if we are going to talk about velocity time graph or something like that, it involves all the formulas of physics. Okay, means now whatever we have learned, we'll have to apply all those kind of things over here. Okay, so today's date, I think it is August 5. Okay, oh man, it is already August 5 and still we are on motion in 1 day. Okay, we have to go very fast. Okay, now look over here. So 2 to 3 formulas I gave. First, velocity, we know it is equal to acceleration into time t. Velocity is also equal to displacement by time. So let's suppose if you have velocity time graph, let's suppose you have velocity time graph. If you have velocity time graph, then remember that first important thing, if you find what is the formula, like I can write acceleration is equal to v by t, and what I can write displacement is equal to velocity into time. Okay, so what is going to be there? Slope of velocity time graph, slope of vt graph is going to give you what? Acceleration, while area of vt graph, is going to give you otherwise displacement. Okay, means two things we can extract from velocity time graph mainly. One, if I calculate the slope, I'll get acceleration. If I calculate the area, I'll get the displacement. This is the main important factor about the velocity time graph. Okay, moving to that, let us start. So first case, when particle is at complete rest. Okay, means particle is particularly at rest, then what will be the velocity time graph? You are going to say that always its velocity is 0 if time increases. Okay, what is going to happen? Always its velocity is going to be 0 whatever time it is. So how I'll draw that graph? So look over here. At t is equal to 0, velocity is 0. At t equal to 1 second, velocity is 0. At t equal to 2 second, velocity is 0. At t equal to 3 seconds, similarly, all the time velocity is always 0. So I'll get a line, a straight line, just parallel to the time axis or lying along the time axis. Are you able to understand it or not? Tell me, everyone.
Yes, sir.
Yes or no?
Yes, sir.
Okay,
Yes, sir.
1 minute. Okay, so this is the most important factor about the velocity time graph, that if like all the objects are at complete rest, the velocity will be always 0, and although the time increases. Second case is, let's suppose the particle always travels with uniform velocity, with uniform or constant velocity if I say. Okay, means for the particle, let's suppose t equal to 1 second, velocity is equal to 5 second, 5 meter per second. T equal to 2 second, velocity is still same. T equal to 3 second, velocity is still same. That means what? Whatever time it is, I have the velocity equal to 5 meter per second. So let's suppose if I draw the velocity time graph of that, what it will be like? I will have the initial velocity at t is equal to 0, 5 meter per second. Let's suppose here I have 5 meter per second. For every time, for t equal to 1 second, I have 5 meter per second. For t equal to 2 second, I have 5 meter per second. For t equal to 3 second, I have 5 meter per second. So what will be the graph if I draw it? It will be always a constant line or a straight line parallel to the time axis. Word or not? Remember that this represents one more thing that here slope of VT graph in second case is equal to how much? Wait, no one will tell the answer. Afan will tell. Afan, the slope of VT graph in this VT in second case, what is it? Tell me. Can you tell me what will be the answer of slope of VT graph? Afan, hello.
Sir, 1 minute, sir.
Tell me, Afan, what should be the answer? Slope of VT graph. Okay. First important thing, slope we know now it is perpendicular by base. Here, is there any kind of rise of perpendicular? No, there are no perpendiculars over here. It is a constant flat graph. If it is a flat the curve or a flat straight line parallel to any of the axes, slope becomes always zero. Remember that. Okay. So slope of VT graph over here is equal to how much? Wait, if it is parallel to x-axis, remember that in a graph. Wait, I'll teach you guys. Let's suppose if I have this x-axis, wait, x, this is y. Okay. So if I draw a straight line parallel to the x-axis, that means what? What is the angle made, like if this line, if I consider about this line, what is the angle made by this line with the x-axis? It is equal to theta is equal to 0. So if theta is equal to 0, you know that tan theta is also equal to 0 for theta is equal to 0. Tan 0 is what? Tan 0 is nothing but 0 only. So if it is 0, that implies what? Slope is not defined. Yes or no? Sorry, slope is not defined, not. Slope is what?
The slope is 0. So
0.
acceleration also 0.
Yeah. Slope is 0 over here. Why? Because perpendicular are not available over here. Now, if the line becomes parallel to the y-axis, okay. If the straight line, if I ask you, what is the slope for this line? For the line parallel to the y-axis. Now, here also, what is the angle made with respect to the x-axis? It is equal to theta is
Not defined.
90 degree.
90.
So tan 90 is how much? It is equal to undefined. And of course, here base is not there. If base is not there, if you put a particle, it is always going to fall vertically over here. That means what? Slope of line, slope of these lines are not defined. Are not defined. So two cases are there. One, parallel to the x-axis, theta is 0, slope is 0. But if the theta becomes 90, then slope becomes undefined. Understood or not? Tell me. Understood now?
Yes, sir.
Got it?
Yes, sir.
Yes, sir.
Radha and all. Radha, Sparsa, Sneha. Got
Yes,
it or
sir.
not? Okay. Now, based upon these things, wait, I'll kill you off on next time. Got it or not? Okay. Next thing, previous case. So slope of VT graph over here, it is going to be how much? It is going to be equal to 0. Why it is going to be equal to 0? Because it is parallel to x-axis. We know that slope of VT graph gives acceleration. That means what? Acceleration is 0. Also, you can say, you try to see initial velocity in this graph. This is my initial velocity. Initial velocity is equal to final velocity over here. So there is no change in velocity. If I have considered constant velocity, that means what? Initial velocity is equal to final velocity. Now, if initial velocity is equal to final velocity, what do we know? That acceleration is equal to v final minus v initial by time. So for that case, acceleration becomes 0. So in this case, acceleration means if you have a constant velocity, acceleration is 0. And remember that this kind of motion where if we have a constant velocity, we travel equal distances in equal time. If we travel equal distances in equal time, that means what? If we have a constant velocity graph, we are actually talking about uniform motion. Which kind of motion, guys? Uniform motion. So in uniform motion, you have to travel equal distances in equal time. Understood or not? Tell me. Full. Are you able to understand this or not? Tell me, everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Sneha, Sparsa, Hitesh, Radha. Okay. Pranita, look into the next graphs. Okay. Try to look into
Yes,
that.
sir.
Okay. Now, third case. Now here, let us take an again example like that way, which we discussed previously. Okay. Now, let's suppose this is the total distance of the particle. Now I am traveling this distance in three parts: d1, d2, and d3. Remember that time of traveling are going to be similar. Okay, t2 is there, and here t3 is there. Okay. Now, in this time t1, I have velocity v1. In this time t2, I have velocity v2. And in this time t3, I have velocity v3. Now, if I am traveling in such a way that d1 by t1, sorry, v1 by t1 is equal to v2 by t2 is equal to v3 by t3. If this condition is followed over here, means if v1 is equal to v2 is equal to v3, and this t1 and t2 and t3 are also similar, so what is going to happen? We know now that velocity by time is equal to acceleration. So here I will get one acceleration, here also I'll get one acceleration, and here also I get one acceleration. Remember that I'm not talking about total velocity. I'm talking about the interval velocity over here. Means V1 over here in this gap, V2 over here in this gap, V3 over here in this gap. I'm not talking about total velocity from this point to this point. Got it or not? So when I'm talking about velocities in equal interval of time, if these velocities are also equal, I get a graph for constant acceleration. Means we get a condition for which kind of acceleration? Constant acceleration. Now, constant acceleration means what? That ratio of velocity with respect to time will be always constant. If it is a constant acceleration, then remember that what kind of VT curve I will get? I will get a linear VT curve. What I will get, guys? I'll get a linear velocity time curve. So look over here. Here, if I have velocity v equal to 0, at t equal to 1 second, I was having 1 meter per second. T equal to 2 second, I was having 2 meter per second. At t equal to 3, I have velocity 3 meter per second. So for that kind of cases, we see that velocity is increasing rapidly, but also with a constant ratio. Then that is why they have a linear graph over here. Understood or not? Tell me so. So what kind of graph it is? Linear. What is constant? The ratio of velocity with respect to time is constant. Okay. Means at t equal to 1 second, I have velocity 1 meter per second. At t equal to 2 second, I have velocity 2 meter per second. So 2 divided by 2 is 1. Understood or not? So here, it is not the points which are equal. It is the ratio this time equal. Understood or not? Tell me yes or no. Yes or no, guys? Are you able to understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. Sneha, are you able to understand or not? Esposa? Okay. Wait, wait. Okay. Let us start. Okay. Wait, let me put my phone on silent. Okay. Now look over here. Next case. So when we have similar ratios, then I'll get a linear graph passing through the origin. and it will be a straight proper linear way. Okay, so this was the case of constant acceleration. Remember that one most important thing. Can I say that if I'm following a constant acceleration graph, then I'm having a uniform motion? Can I say that? Tell me, any guys, anyone over here? Can you
Sir, repeat once more.
can you say that if I am following constant acceleration graph, then I'm moving with uniform motion?
Yes, sir.
No, sir.
The answer is yes or no.
No. No.
Yuvraj, yes or no?
No.
Sneha, yes or no?
Sir, no.
Sneha, Sparsa, Radha. Okay. Now look over here. Try to understand this. Eh? When I'm asking to reply, you should reply. I'll kill you guys. Ratio of velocity with respect to time. Now, when I'm saying this particular ratio, when I'm talking about this particular ratio, when I say it is moving with constant acceleration, what you will see in upcoming classes that this acceleration follows half of, like with respect to this acceleration, I have the displacement equation as s is equal to half at square, not half of 80 or something like that. We have displacement directly proportional to time square for this kind of graphs for having a acceleration. So this means what? We didn't follow equal distances in equal interval of time. So remember that when you have a constant acceleration, the body will move rapidly and you are not going to have similar displacement in similar time. So that is why these are cases of non-uniform motion. This is the case of non-uniform motion. In uniform motion, velocity remains constant. Here, the ratio of velocity by time remaining constant. Got it or not? Okay, velocity is not remaining constant over here. Previously, here I can say that I have a uniform motion. That's what I have written. It is a uniform motion. Why? Because I was having a constant velocity. Okay. But what is constant over here? Since acceleration is a constant, I will write it is a uniformly accelerated graph. Accelerated graph. Got it or not? Everyone got this or not? Tell me yes or no. Parinita, got it. Radha,
Yes,
Parinita,
sir.
Sneha, okay or not? Sparsa, okay.
Yes, sir.
Yes,
Yes, sir.
Okay, Ankit, okay. Okay, guys. Now,
Yes, sir.
moving to next point. Can I move to next graph? Now the difficulty starts. Okay. Okay, Sagalaga boom boom. So this is velocity. This is time. Now, can you tell me? Can you describe this graph? What is the meaning of this graph?
That means a body is having initial velocity.
A body is having a initial velocity. Wow, great. Great, Sujit. So look over it. What is this meaning of this graph? Again, similar to previous question, similar, like I started from here and went ahead. But here, try to understand at t is equal to 0, velocity is also 0. At t is equal to 0, velocity of the body is also 0. But I can do what? At t is equal to 0, I can have some kind of velocity, initial velocity, let's suppose some amount, v meter per second. Okay, v naught meter per second. After that, I can like accelerate with uniform acceleration, yes or no? So this is a graph, what having initial velocity v naught. It has initial velocity v naught. Second point, again, it is a uniformly accelerated graph. Okay, second point, sorry, third point, non-uniform motion. Okay. Now, if someone asks you, let's suppose this is my time t equal to 0, velocity v naught is there. At t is equal to some kind of capital D, you are having some kind of velocity v over here. Okay. So can you tell me what is the displacement curve over here? Can anyone tell me what is the displacement over here? So simply, what I will do, I know that displacement means area under the graph, correct or not? Okay, so this displacement means this area. Like let's suppose if someone asks you, what is the total displacement in velocity time graph? Just say this reason, this is the area and this area is going to give you the displacement over here. Now what will be this displacement? Simpler, yes or no? This displacement will be sum of area of triangle, A of triangle plus this bigger triangle, area of this triangle plus area into area of this rectangle or not? Tell me yes or no. This
Yes, sir.
whole area can be divided into two parts. One area of this triangle and area of this rectangle. Got it or not? Okay. So area of triangle is what? Half base into height plus area of rectangle is what? Length into breadth. But here try to understand that what is base over here? This is my base. Yes or no? Try to understand what is base over here. This is your base over here. Base means what is the length of the base? This is equal to t. What is the height? It is equal to, try to understand this whole b. From here to here it is v. From here to here it is v naught. So this will be, height is v minus v naught. Got it or not? So therefore half of base is what? T. And this is nothing but v minus v naught plus length is again what? Now try to understand. For this rectangle, length is again, it is equal to time, and breadth is equal to nothing but it is equal to v naught. So it will be v naught into time. So now I get the relation v naught plus half of t v minus of v naught. Now you know that what is the relation? That v minus v naught divided by time is equal to what? It is equal to acceleration or not? So I can do what? I can multiply by t over here. I can divide by t. So I get the relation v naught by t, half of at square, and that is nothing but my displacement. So here from this graph I get my first equation of motion, or you can say second equation of motion for an accelerated particle. Got it or not? Yes or no? Are you able to understand or not? Tell me.
Yes, sir.
Yes or no, guys?
Yes, sir.
Yes, sir.
Everyone. Sneha, Sparsa,
Yes, sir.
Parinita, okay or not? Okay. So basically, what we observe, we know that acceleration is nothing but final velocity v final minus v initial divided by time taken. From this, I can get my first equation of motion, that is v final is equal to nothing but v initial plus at. Second equation we get from uniformly accelerated graphs. Okay, what I observe that this displacement is nothing but area of this triangle plus area of this rectangle. But if we solve this, we summarize this to one biggest equation, that displacement for uniformly accelerated graph is v naught t plus half at square. This means in simple form s is equal to ut plus half at square. You might have done the derivations in your class 9 also. Okay, but we are going to see the applications of it. Okay, basically perfectly we are trying to understand but what is going to happen. Now here, since there was initial velocity, okay, if someone asks you that, okay, I'll come to this displacement time graphs later, okay, or not. So it is not a good idea in doing velocity time graph. See, previously we have done all the displacement time graph without acceleration, means we were getting the acceleration but we were not trying to understand it perfectly. So this time we'll be perfectly understanding what is displacement time graph with acceleration and with retardation. Okay, what will be the curves for it? Okay, so we are going to understand it in last class. Okay, so now moving to next point. Now similarly, let's suppose if I have two cars starting from the same, like you have two cars. Okay, so one car start from this point, another car P start from this point. If someone asks you which car is faster, which car have more acceleration, can you tell me now? What will be the answer?
P. P. P.
Sir, P.
P, yes. Sparsa, P na? Sparsa, what should be the answer? Sparsa, Sneha, Radha, Parinita. Which car is moving faster? Simple logical question. Sir, we know that if we have velocity time graph, okay. Yuraj Singh, P, yes, correct. Okay, now try to understand. See, car P has this initial velocity, V naught P. Car Q has this bigger initial velocity, V naught Q. But one thing is very much uncommon over here, that when you draw the right angle triangle, I have told now which car is having more acceleration. Acceleration means what? If you have velocity time graph, acceleration will be nothing but slope of VT curve. Okay. Now here in these two, first try to draw the triangle. What you observe, that the triangle of P car is much more, means this slope of P is much more as compared to the slope of Q car. So that means what? Acceleration of P, like what I'll write is, wait, uh, tan theta of P is much more greater than tan theta of Q this time. But here tan theta of P means velocity of P by time of P is much more greater than velocity of Q divided by time of Q. And this implies what? Acceleration of P is much more than acceleration of Q over here. Understood or not? Tell me. Yes or no? Although the P was having less initial velocity as compared to the Q car, but the P is moving faster because it has a greater acceleration. Understood? Guys, understood or not? Radha,
Yes, sir.
Yes, sir.
Sneha, understood? Sparsa,
Yes, sir.
Nisant, Afan?
Yes, sir.
Okay. So these are the main points. See, I have I have been talking about now uniformly accelerated. We discussed also if we have two different initial velocities, which one is going to move faster. We have understood about that also. Next one, coming to next case. Okay. Now this time, yes. Now here we are starting from curvical paths. Now first important thing, if you have a velocity time graph and it is a curve, then you know that either it is a non-uniform acceleration, or what is the point over here? If you have a curve, this means what? Curve in Vt. Okay. So first conclusion is just simple, just one line conclusion: non-uniform velocity. Non-uniform velocity. And in non-uniform velocity, non-uniform acceleration also. Got it or not? Non-uniform acceleration only when Vt curve is rising up. Vt curve is rising up. Got it or not? Okay. So first, if you get a curve in velocity time graph like this kind of curves, it is a case of non-uniform velocity. If you have a non-uniform velocity, then two things can happen. Either the velocity will decrease non-uniformly, either it will rise up uniformly, non-uniform. So if it is going to rise up non-uniformly, then I'm going to call it as non-uniform acceleration. If it is going to like rise down, or it is going to slope down in the velocity time graph, then it will be having non-uniform retardation at that time. So can you tell me like what is happening over here? Let's suppose this is my point C and this is my point D. So which one is having higher acceleration? Can you tell me?
The point D is having real acceleration. Point D.
Yeah, yeah. Try to understand. We know again our concept of slope, that if I have a slope, if I have a higher slope in VT graph, higher acceleration. If I have a lower slope in VT graph, lower acceleration. To understand about that, I'll construct one right angle triangle at point C. What we observe, that the slope of the length of hypotenuse of this particular point D is much more like angle, sorry, the angle made with the x-axis with of this hypotenuse is much more as compared to the angle made with the hypotenuse of this point C. So tan theta at point D is much more tan theta at point C. That means what? That velocity at point D as compared to time at point D is much more than velocity at point C divided by time at point C. This means what? Acceleration at point D is much more greater than acceleration at point C. So that is the most important case. What is going to happen? That acceleration at point D is much more greater than acceleration at point C. If this is happening, this means what? Acceleration is also increasing in or not. So in this graph, what is happening? Acceleration is increasing along the direction of motion. First important conclusion. Understood or not, everyone?
Yes, sir.
What is happening since the slope are increasing? What is happening? The acceleration of the body is increasing along the direction of the motion. Understood or not? So how to the acceleration of the body at instant t1 and t2 is given by the slope of tangents drawn to the point at the curve at this point C and D as A1 and A2 respectively. So we observe that the slopes of D is greater than slope of C. So that is why it is a graph of increasing acceleration. Understood, everyone? Nissan, Parinita, Radha, Sneha, Sparsa? Go ahead or not, tell me. Everyone.
Yes, sir.
Yes, no? So these are,
Yes, sir.
if you have any kind of doubt, you can ask me.
Yes, sir.
Okay. Wait. So please try to understand every time when I'm saying that these are not like if I get a curve in VT, it is a non-uniform velocity, first important thing. Now the velocity will have two types. Non-uniform velocity will have two types. Either it will be accelerating or either it will be retarding. So based upon both of the cases, we can draw the graphs like this. Okay. Now moving to next point. Oh, so now this case. Now try to understand what is this.
Non-uniform decreasing acceleration.
Wait. Yes, man.